Hello everyone. In this video we are going to learn how to plot the graphs of position time graph, velocity time graph, and acceleration time graph of a constant velocity. But first we need to understand what is a constant velocity. So when an object is moving at a constant velocity, that simply means it is moving at a constant speed. And now if something is moving at a constant speed, that means it will change the same distance at the same time. So what I mean is that if the object is moving from point A to B for a distance of 2 meters, and then if it also move again from point B to point C, a distance of 2 meters, it means that it's going to cover the same distance of 2 meters at the same time. For example, you're going to say now from A to B, it will take 1 second. Therefore, it will also mean that from B to C, it will take 1 second. So that is what we mean about a constant velocity. So the car will be traveling at the same speed, and then it will cover the same distance at the same time. So that is a constant velocity. So now, let us look at a position time graph of a constant velocity. So we're going to say on our vertical line, we're going to have position, which is in meters. And then on the x-axis, we're going to have what? Time, which is in seconds. So let us use this scenario that we have made here to actually plot this position time graph. So at point A here, we know the position is going to be 0 because that is our starting point. And then our time is also going to be 0. So the initial point of A and the initial position of A and the time will be at 0 is to 0. And then now, if the object moves from A to B, it will cover a distance of 2 meters. And then if it moves from A to C, it will cover the distance of what? Of 4 meters, because from A to C, the distance will be 2 plus 2, which is 4 meters. So this is going to be 4 meters at point C. But now the time it will take to move from A to B, it will be 1 second. And therefore, the time it will take to move from A to C, it will be 2 seconds. So now the point that we have at what? At point B is going to be what? The value of the time is 1 second and the position is at 2 meters. Then also at point C, we're going to have the time to be 2 seconds and the position will be 4 meters. So if you want to plot this position time graph of a constant velocity, you will always get a straight line. So if we join this line, we are going to say now this object is moving at what? At a constant velocity. So it is going to have a straight line on a position time graph. So remember, this point is B and this point is C. So the position time graph of a constant velocity, it is a straight line. So a straight line, that is what? That is at an incline. For example, you see now this is an increasing straight line. So from this position time graph here, if the question asks you to calculate the velocity from the position time graph, so remember, velocity by definition, velocity is the change in displacement over the change in time. And now the change in displacement simply means a final displacement minus initial displacement over final time minus initial time. So if you look at our graph here, the position here is the y-axis. So remember now, if you are looking for the gradient of a line, you say now the gradient is going to be what? The change in the y over the change in x. So in this case, this will mean now is the gradient of the position time graph. So the velocity is the gradient of the position time graph. So in this case, if we had to calculate the velocity of this car that is moving from point A to C, using this position time graph, we will say now the area under the curve is given with this equation here. The final, not the area I mean, I'm saying now the gradient of this line is going to be given as the final displacement minus initial displacement over the final time minus the initial time. So if we substitute the final displacement here is going to be how much? We can say this final displacement is at C and then initial displacement is at A here. So we are going to have what? We're going to have what? The final displacement as 4. So we're going to say this is going to be 4 minus the initial displacement, which is at 0, because at A we have 0 is to 0, all divided by what? The final time, which is how much? Which is 2 seconds, and the initial time, which is 0 seconds. So if we put this in a calculator, we'll get that the velocity is going to be 4 over 2, which is 2 meters per second. So now, it doesn't matter which 2 points you use. Let's say, for example, instead of using point A, we can also use point B and point C. But now we have to identify that, okay, point C is the one that is the final, and then point B is the initial. So if you want to calculate the velocity using point B and C, we will say now, okay, velocity is also given as what? As a final displacement minus initial displacement over final time minus initial time. So if we substitute what we have, we're going to say now the final displacement is at C, and then at C the final displacement is 4, and then the initial displacement at B is how much? Is going to be 2, and then also the final time at C is going to be 2 here, and then the initial time at point B is going to be 1, so we're going to have minus 1 there. So if we put all this into the calculator, we will see that 4 minus 2 is going to give us 2, and then 2 minus 1 is going to give us 1. And therefore, the velocity will also be 2 meters per second. So if we have a constant velocity, we are going to see a constant velocity in a position time graph with a straight line. And then from this straight line, for us to calculate the velocity, we can just use the gradient of the straight line. So now, let us look at what? At a velocity time graph of a constant velocity. So now, if we have a velocity time graph, that means now on the y-axis, we are going to have velocity, which is measured in meters per second. And then now at the horizontal, we're going to have what? A time which is measured in seconds. So remember now, we are having a constant velocity. So if we have a constant velocity, that means our velocity is going to be 2 meters per second throughout our entire motion. So on the velocity time graph, you're going to say now, this thing here is going to have a velocity of 2 meters per second, but it's going to have the velocity of 2 meters per second through the whole time. So we're just going to have a what? A straight line that is moving like this. So this will represent the velocity time graph of a what? Of a constant velocity. But remember now we have the first position, which is position A at 0, and then the second position we have it at 1 second, which is position number B, and then now the third position we have it at what? At 2 seconds, which is position number C. So now if we want to calculate, for example, the displacement at 1 second using this velocity time graph. So from a velocity time graph, if we want to get the position or the displacement, we are going to calculate it by using the area under the curve. So if we want the position at 1 second, that means at 1 second here, we are going to make a line like this up until the what? Where the velocity time graph is. And then you see now, if you make a line at 1 second, we're going to get a shape which is called a rectangle. So the rectangle here is going to be the area under the curve at 1 second. And then if you calculate the area under this curve here at 1 second, we will get the position of the car at what? At 1 second. So now how do we do that? Remember now, this is going to be what? This is going to be a rectangle. And then if you want to calculate the area of the rectangle, you just say what? The length multiplied by the breadth. And then we can see now, our breadth here is going to be 1 second. And then now our length here is going to be 2 meters, or 2 meters per second, I mean. So you're going to say now the area, it will be given as what? Length times breadth. And then now the area of length times breadth, it will be what? It will be, the length will be 2 meters and the breadth will be 1 second. So the area under the curve at 1 second is going to give us 2 meters. So this will mean now, at 1 second, our car will be at the position of 2 meters. So remember, if we look at the previous graph here, at what? At 1 second, our position was how much? It was 2 meters. So if you have a velocity time graph, for you to get the position from a velocity time graph, you only calculate the area under the curve. So from a velocity time graph to get a position, you calculate the area under the curve. So lastly, we're gonna look at what? At when we have a constant velocity, but now we are looking at what? At an acceleration time graph. So at an acceleration time graph, that means we're gonna have what? Acceleration here, and then acceleration is measured at meters per second squared, and then here we're gonna have time in seconds. So remember now, if we have a constant velocity, that means now we don't have acceleration, because acceleration is given as the rate of change in velocity over the rate of change in time. So if the velocity is constant, this simply means that the velocity is not changing. So we're going to have what? The change in velocity as 0. So if we want to calculate acceleration here, we're going to have 0 over change in time. And then we'll always find that for a constant velocity, the acceleration will always be 0 meters per second squared. So we will see that for a constant acceleration, for a constant velocity, our acceleration is always going to be 0. So that means we're going to have a straight line here at the 0 line. This will indicate now the acceleration at whatever point is going to be 0. Let's say, for example, here we have point A here at 0, and then we have point B here at 1 second. And then we have point C here at 2 seconds. So for the entire motion here, the acceleration will be what? Will be at the 0 line here, because now the velocity is constant. And for a constant velocity, the acceleration is 0. Thank you very much.